Hi everyone, welcome back to the Opamp Masterclass series. Today, we are going to discuss about the inverting amplifier design with feedback. So, what are the parameters that we are going to discuss about the inverting amplifier? The first and foremost thing is that the closed loop gain. Closed loop gain. What is the another important one? It is input resistance with feedback. If we just look at this in the open loop, uh, input resistance is infinity. When it is connected with the negative feedback, the input resistance varies. Third one, output resistance with feedback. Fourth one, the bandwidth. Bandwidth with feedback. And one more last is that output offset voltage. Output offset voltage with feedback. So these are the five fundamental things that we are going to study on the inverting amplifier. To start with, we need to understand what is the closed loop gain. Closed loop gain means it is ACL, which is nothing but equal to output voltage divided by the input voltage. Let us study the open loop gain. Now, let us design this inverting amplifier using the common resistors. Now, if you just look at here, it says inverting amplifier. That means you have to connect the input to this inverting terminal. This is inverting terminal. This is non-inverting terminal. You have to connect the input to the inverting terminal. This is V in and this is connected to ground. Fine. Now, once this is connected to the input and the other one will be grounded, right? There is no connection to the non-inverting terminal. And this is V naught. We said that we have to give the feedback. So can we attach this feedback? Anyway, this is grounded. We have to connect the feedback here. Can I call this as RF? Okay, this one I can call it as R1. So can I call this as V in? So can I call this as I in? This is IB. This is IF. This is terminal V1. This is terminal V2. Now the circuit is set. Okay, to start with, what is gain? Closed loop gain, ACL, or ACL is equal to output voltage divided by the input voltage. This is what is called as the closed loop gain. To start with, the current which is branching out here, I in, IB, and IF, I think we can apply the Kirchhoff current law. What is Kirchhoff current law says the incoming current is equal to the outgoing current in a network. Fine. It is balanced. So it is I in incoming means which are the incoming? It is only one incoming. Incoming one, and IF and IB is outgoing. IF plus IB. The input bias current is very, very, very low, right? Because of the input resistance is very high. I can make this as 0. I in is equal to IF. So I in is equal to IF. It's done. So let us understand what is I in. I in is nothing but equal to the voltage drop across this resistance. So what is the voltage drop across this resistor? It is nothing but equal to, so I in is equal to, it is V in minus V1 divided by resistor R1. So what is IF? IF is equal to, this is IF. Again, the current is going from here to here. Start with V1 minus V0 divided by RF. Fantastic. Now, let us put these equations in this equation 1. It is V in minus V1 divided by R1 is equal to, it is V1 minus V0 divided by RF. Okay, that's fine. Now it's so let us simplify these equations. I'm just taking to this side and R1 is this side. Simple. Okay, this is, we have got this particular one. Now let us try to understand from the open loop equations. What is that open loop equations says that it is very important to understand the open loop equations. So the open loop gain is nothing but equal to V naught divided by V difference. That is V naught divided by V1 minus V2. This is the open loop equations, right? So it is something like this. It is V1 minus V2 is equal to, it is V1 minus, it is V naught divided by A. What is actually V2? V2 is grounded here, nothing but 0 volt. I can forget this 0 volt. So it is V1 is equal to output voltage by V0. So can we have this formula? I think this is 2. Why don't we substitute here V1 into this particular one? It's simple. It is RF. What is V in? It is V in minus what is V1? We can substitute here. It is V0 by A, which is equal to, it is R1. V1 is what again? This is V0 by A. This is V0 by A minus, it is V0. Okay. So now we just have to rearrange, nothing else. Let us simplify this. It is RF minus V1. It is RF into, it's V0 by A, which is equal to, it is R1 V0 by A minus, it is R1 V0. So let's take the V0 on one side and VF on one side, because we want to do the V0 and V in this particular format, right? So then only we can able to find out the ACL. So can we put V0 on the other side and V in on the other side so that we can have the a proper formula, a simplified one. So if you just push this particular to the right hand side, it is R1 V0 by A plus, it is RF V0 by A minus, it is R1 V0. So can I take the V0 common here? Everywhere V0 is common. V0, it is R1 by A plus, it is RF by A minus, it is R1. So we have to simplify this formula. Again, V0 is equal to, it is A, it is R1 plus RF minus A times R1. So here, let us bring this now. RF V in is equal to V0 into, it is R1 plus RF minus AR1 divided by A. Now, can we have the V in and V0, just focus on these two. So we have to arrange in a fashion like this so that you can get the closed loop gain, as simple as that. Now, V0 by V in is equal to, it is, I'm sending this one, ARF divided by, it is R1 plus RF minus AR1. So look at here, you got this particular formula. This is nothing but your closed loop gain, which is equal to, now we have to make some kind of assumptions. What are those things? R1 and RF as compared to the AR1 is very, very less. Why? EA is in terms of it's an open loop gain. It is in terms of thousands, thousands, thousands multiplied by R1. So imagine the value will be very huge as compared to this particular resistor. This is negligible. So I am going to neglect this value. Minus is there. Don't forget to take that signs always. A and A is cancelled. Closed loop gain is nothing but equal to minus RF divided by R1. This is the formula for the closed loop gain. You can see this ACL is minus of RF divided by R1. What is this minus signal or symbol indicates? This indicates the phase reversion of the input. What do you mean by that? If the input is actually of this one, the output will be amplified version of this one. The phase has been inverted here. This is inverted by how many degrees? Inverted by 180 degrees. That is why this particular symbol is very necessary for the inverting amplifier. In the non-inverting amplifier, when we did that, it was just the gain was ACL is equal to, it is 1 plus, it is RF divided by the R1. So this was the non-inverting closed loop gain. But here there was no minus. But when we come to the closed loop gain for the inverting amplifier, you can see minus 1. Thank you so much. Please subscribe to this channel for more designs. I hope you understand this inverting amplifier design with feedback. Please watch it again so that you will understand the closed loop gain equation. Thank you so much for watching it.